Hi everyone, I'm Wani. We are talking about categorical data analysis. When you have categorical data, there are three kinds of tests available. One is goodness of fit test, and the second, independence test. Third, homogeneity test coming up next. Okay, let's see what independence test. It is a very useful tool to check two variables are independent or not. So main purpose of testing categorized data is likely to be the test of independence. The test of independence examines whether two variables, A and B, can be considered independent of one another. That is, when variable A is classified into P categories and variable B is classified into Q categories. Okay, P categories, Q categories. The resulting table is called contingency table. Dimension P by Q. This is a form of contingency table. There are A and B. A classified into P categories. B categorized Q many. Okay, so we call P by Q contingency table. And what is this? This is sum of n. Okay, ni plus is sum of ith row, and n plus j we have two subscript. N plus j is the sum of jth column, sum of this, and ni plus is sum of this row. Okay, and the total is n. N is a sample size. So we have n many samples, okay, and observe about variable A and variable B. Then we can make this kind of a contingency table. Get it? When two variables A and B are organized in a contingency table, testing whether A and B are independent is called the test of independence, or contingency table test, or some people says chi-square test because it is a famous thing. Let's denote P. Random variable xij equal to small xij is small pij. Say they are probability pi, p11 and p1j, pi1 here, pij, something like that. Okay, we did it for each category. Number of appearance, observed frequency, random variable x, and probabilities p1, p2, pk. That what I mean here. Okay, here. In this case, the hypotheses are H0 should be A and B are independent. For any your assertion or claim, it is fixed. H0, A and B are independent. Okay? What is A? When A and B are independent, then the joint probability, this is a joint probability. Pij equal to Pi times Pj for all ij. This is the definition of independence we studied. Versus H1, A and B are not independent. Okay? Okay, say again. We have n many samples, and we observe values for variable A and B. That's why we get joint probability. Okay? Xij is follows joint probability distribution function. In this case, the test statistic and its distribution as follows. Test statistic in this case means for categorized data is chi-square. We already studied chi-square here. Goodness of fit test chi-square test statistic and its distribution, chi-square with degrees of freedom k minus 1. What is the form of this chi-square? Chi-square is the sum of xi, observed frequency, ei, expected frequency, squared divided by expected frequency, ei, right? So this is the basic form of chi-square test. Same thing here. Now we have two subscript. Xij is the observed frequency for ith row and jth column. Eij will be expected frequency for ith column, ith row and jth column, squared divided by expected frequency. Sum I from 1 to P, sum J from 1 to Q. They are PQ many cells here, right? So it is the same form, basic form of a chi-square test. And it follows chi-square distribution with the degrees of freedom n minus 1 times Q minus 1. They are how many? P many categories. So the total sample is n. If p minus 1 many, some of these are determined, then the last one, in other words, summation n I plus I from 1 to p equal to what? N. N is sample size, fixed value. So n minus 1 independent from this, and the q minus 1 are independent for column. So the degrees of freedom, p minus 1 times q minus 1. Now, under the assumption, always we test hypothesis under the assumption H0 null hypothesis is correct. A and B are independent. Under this assumption, we can only calculate the expected frequency Eij. We will get this value, observed frequencies, but we do not know expected frequencies, Eij. In other words, if A and B are independent, the expected frequency Eij is what? N times probability of this cell. This cell Pij, right? N times Pij is expected frequency. It is what? Under the assumption H0, N times Pi Pj, right? And we have to estimate the expected frequency like this. Expected frequency will be what is this? Eij hat is n times, what is it? Pi hat. Pi hat is ni plus over n, okay? Ni plus over n. What is Pj hat? This one. This one is n plus j over n. So we may get estimated value of expected frequency. Then we will use this estimated value here, so we can get the value of a chi-square test statistic, and we can, perform chi-square test. I'm going to take some examples later for this kind of things. By the way, how to get contingency table? Here, we have two continuous variables, age and income. But age can be classified into 6 categories, and income data can be classified into 5 categories, right? Yeah. So we may get the contingency table for age and income variable. So we may perform a test of independence between age and income. This is for example. All right. So not that hard. But it is this is test of independence is important in your analysis sometimes. Okay, this is it today. Thank you. Bye.